We're still doing the same topic, limits involving absolute values. So we need more example. We're going to do example 4, 5, and 6. Again, we need to do, for example 4, we need to find the limit of 3x minus 15 over absolute value of x minus 5 as x approach 5. Again, when x, if you plug in 5, you'll get 0 over 0, right? Which is in determined form. So we need to do limit as x approach 5 from the right side and left side. Why? Because it doesn't, well, let me do this. As x approach 5 of 3x minus 15 over absolute value of x minus 5, as if x absolute value of x minus 5 is equal x minus 5 if x minus 5 is bigger than 0, which means x is bigger than 5. Now absolute value of x minus 5 is equal minus x minus 5 if x minus 5 is less than 0, which means if x is less than 5. So it depends if we're approaching x from the left of 5 or right of 5, absolute value of x minus 5 takes different values. So therefore here, if we do right side of 5, then the limit of 3x minus 15, now absolute value of x minus 5 becomes x minus 5. As x approach 5 from the right side, it's still 0 over 0. So what we do here, let's do it here. We can just factor. If you factor 3, you get x minus 5 over x minus 5 as x approach 5 from the right side. Simplify this, and then you'll get the 3. Now let's do the limit as x approach 5 from the left side. This is going to be 3x minus 15. Now absolute value of x minus 5 becomes minus, right here, minus x minus 5. So minus x minus 5, because we're approaching 5 from the left side, of 3x minus 5, which we're going to factor the 3, we get 3x minus 5. Now all we do, we simplify this. 3 over negative 1 is just minus 3. Therefore, we can go back here and say the limit does not exist. Therefore, the limit of 3x minus 15 over absolute value of x minus 5 as x approach 5 does not exist. So, why it does not exist? Because the right limit is 3, left limit is negative 3. They're not the same. Now example 5 is a little bit confusing. Why? Now we need to deal with absolute value of x. See, if you plug a 1, you're still going to get a 0 over 0. But here it's tricky. Why? Because we know that absolute value of x is equal x if x is positive. Absolute value of x is equal negative x if x is negative. Now, whether you approach one, let's do it two different. Let's do the right side and left side, and you'll see. Even though we don't need to do it from both sides, we could have just said this is number 5 is just equal limit. Absolute value of x will be always x if you're approaching one from right to left. Let's do it this way and I'll show you the other way. So you could have just said it's x minus 1 over x minus 1 as x approach 1. Why? Because it doesn't matter if you approach one from the right side, means you're here. This is what we mean. X approach 1 from the right side, you're between 1 and 2 somewhere. You're closer to 1 actually. You're even closer to 1. Here, absolute value of x is equal x. Why? Because x is negative. Now, what about left side? Left side means you're here, between 0 and 1. And you're even closer to 1 from left side, like 0.9, 0.999. Absolute value of x here is also equal to x. Absolute value of x equal negative x from here. and we don't care about those values. This is what absolute value of x is equal to negative x. We don't care about those. All we care about is here, left side of 1, right side of 1. So if you're approaching from the right side, absolute value is equal to x, and then you simplify, you'll get 1. And if you're approaching x from the left side, absolute value of x is still equal to x. And then you're still going to simplify and you still get the 1. So therefore, the limit of absolute value of x minus 1 over x minus 1 as x approach 1 is equal to 1. In example 6, it's the same problem. Just written different way. I did it in purpose to show you. So I'm doing this limit to show you x approach a different number. So let's assume x approach negative 1. Now I'm approaching negative 1. So if you plug it in first, you get 0 over 0. That's not a problem. Now here I'm approaching, x is approaching negative 1 on this side and on this side, or this right side or left side. Now we know as if x is less than 0, all of this absolute value of x is equal minus x. It doesn't matter where you are in there. Absolute value of x is always going to be negative x. We don't care about this side. So therefore, this is going to be equal limit of 1 minus, now absolute value of x is equal negative x over 1 plus x as x approach negative 1. It doesn't matter whether I'm coming from right side or left side. Absolute value of x is equal minus x if x approach negative 1 from the right or x approach negative 1 from the left. It's always going to be negative x. So therefore, this is equal limit of 1 minus x is 1 plus x over 1 plus x as x approach negative 1. And this is, if you simplify this, you're still going to get a 1. Alright, and that's it for these examples.